This demo is a rapid-fire introduction to the Krill software platform for creating decentralized mesh networks of Krill servers that can interconnect as powerful state machines. Krill is built around a simple idea. A Krill server is the central node in your system, and it hosts a graph of child nodes. Each node can have its own children, so you can build real workflows, step by step, without everything becoming one giant script. Today, Krill supports over 30 different node types. Some nodes collect data, some perform actions, and others process or transform information. A key concept is this. When a node executes, it can trigger the nodes beneath it, which is how you build automation chains. If you ever forget what something does, you can learn about Krill just by clicking the avatar. Krill can explain the system as you explore it. Let's dive in. What you're seeing is the Krill Desktop app running on an Ubuntu workstation. On screen, I have 3 Krill servers running at the same time. The first server is a Raspberry Pi, which is great for hardware control like GPIO. The second server is a powerful local server, which is great for heavier processing and fast iteration. And the third server is an AWS EC2 instance, which represents running part of the swarm in the cloud. Before we build anything, one important design principle: Krill is offline first. That means you do not need the internet for a swarm to function. These servers can run entirely on a local network. But if you want cloud storage, remote access, or remote integrations, Krill can connect to the internet just as easily. The first thing we'll build is a simple piece of state, a data point. A data point is just a place to store a value, like a number, a string, or a digital on-off state, so other nodes can read it and write to it. Here I'm creating a data point that stores a number, and we'll use it as a counter. Next, we need a way to trigger work on a schedule, so I'll add a cron timer. A cron timer is a node that fires on a repeating interval, like every second, every minute, or in this case, every 5 seconds. Think of it like a heartbeat for your automation. Every time the timer ticks, it can execute its child nodes. Now I'll add a calculation node as a child of that cron timer. The calculation node is used to compute a value from inputs, usually by reading one or more data points, and then writing the result back to a target. For this demo, the calculation is simple. It reads the current counter value, adds 1, and writes the result back to the same counter data point. So every time the cron timer runs, the counter increases by 1. You'll see the number climb steadily as the workflow executes. Because this server is a Raspberry Pi, we can work with hardware features like GPIO. To demonstrate that, I'll create another data point, this time configured as digital, meaning it only stores 0 for off, 1 for on. In the Krill apps, digital data points show up as toggles, so you can flip them manually. This is useful because it gives us an interactive control we can use as an input into other logic. Next, we'll add a logic gate node. A logic gate reads 1 or 2 digital inputs, like a toggle or a GPIO pin, and writes a digital output to a target. This is a pattern you'll see all over Krill. Many nodes use a source data point for input and a target data point for output. Here I'll choose a NOT gate. A NOT gate simply inverts the input. If the toggle is 1, the output becomes 0. If the toggle is 0, the output becomes 1. So now, when I flip the toggle, the output pin becomes the opposite state. In the app, you'll also see a visual indicator, like a glowing pulse when a pin is high, so it's easy to confirm that the hardware is responding. Now let's go to the other server, because I want to demonstrate one of Krill's most powerful node types, lambdas. A lambda is a node that can run a script, typically Python, inside a secure sandbox. This makes it extremely flexible, because you can implement almost any behavior you want. If you can code it, Krill can do it. Just like before, we'll start with a cron timer as a trigger. I'll create another cron timer, and this one will run every 10 seconds. Then I'll add a lambda node as its child, so the timer is responsible for triggering the script execution. Configure the lambda input-output, and run a demo script. Now I'll configure the lambda. Optionally select an input data point if the script needs input. Select a target data point, where the script's output will be stored. For this demo, I wrote a simple script that generates a random number. Every 10 seconds, the cron timer ticks. The Lambda runs the Python script. The script produces a random value, and Krill stores that value into the target data point. Now imagine these servers are generating lots of data over time. Counters, sensors, scripts, events. At that point, you usually want to summarize and compress information instead of storing every raw event forever. That's where compute nodes come in. A compute node can compute statistics over time, things like averages, min-max, trends, or roll-ups, and then write those aggregated results to a data point. From there, you can forward that data to a cloud server for long-term storage, dashboards, or reporting, while keeping your swarm locally functional even when offline. As the swarm grows, the visual graph can get complex, and that's normal. This is great for observability and seeing data flowing through a system, or when errors occur. Krill gives you another option. Build your own dashboard using an SVG editor like Inkscape. Here's the idea. You design a dashboard layout visually in SVG. You place transparent rectangles where you want live widgets to appear. You bind those rectangles to nodes in Krill. Then Krill overlays live node views directly on top of your SVG design, so you get a personalized control panel that looks exactly the way you want. Krill is built for people who want real automation and process control, without being locked into cloud-only systems. And beyond what you've seen here, Krill also supports things like pub/sub messaging, webhooks, serial devices, Zigbee, and much more. Hopefully this walkthrough makes each step clearer and gives you ideas for what you could build next. Welcome to the Swarm, and thanks for watching.